Hey guys, Dr. J here, and in this video, very short video, we're going to talk about multi-temporal UAS observations. We're going to talk about change detection, time series analysis, and applications of that. So again, this is going to be just a real quick video, and we're just going to kind of hit some of the high points. Basically, the idea here is that you can use UAV data in the same way that you would use any kind of remote sensing data for monitoring changes through time. Time is an important variable in many of our hazards, land use, crops, right? Agriculture, natural disasters. All these things involve a time component. So things are happening in time, things are changing in time, and we want to be able to monitor those. And so whether that's traditional remote sensing or whether that's UAV remote sensing, we can use this remote sensing data to monitor changes through time of many different applications, many different processes. And let me just show you a few examples here. So one example that's very common is elevation differencing. So we can see changes in elevation based on differencing, in this case, structure from motion data and ALS, airborne LiDAR scanning data. So in this case, this is LiDAR and structure from motion point clouds that are being differenced. And the idea here is that we've got this area here, which has blue, so that's changed in elevation. Areas which are in the green are going to be zero elevation change. You can kind of see the histograms here. And then, yeah, some areas are blue and some areas might even be red for an increase in the change in elevation. Here is the same information, but now just shown on a map and highlighting the areas that have specifically changed. So mask the data essentially to show any area which is outside of some particular range of change. And so we can use elevation differencing based on LiDAR, based on structure from motion, based on an existing DEM, for example, to do change detection of heights in this case. Other kinds of changes might be apparent as well, not just elevation per se, but changes in topography, changes in, or not topography, but terrain, changes in terrain due to different agricultural uses, maybe fields that are getting planted with crops, and maybe those crops are growing throughout the time, throughout the year. Here's an example here where we have crops that get planted in a field, and you can see those elevation differences through time. And at some point, those crops get harvested, and so then those elevations again change. We can use this to represent dynamic processes that are changing in time. Now, one of the things that we have to think about when we're doing time series is co-registration. Time series requires co-registered images. And so let me show you what this looks like. We might have orthomosaics or DEMs or images that are overlapping somewhat, but not entirely. And so what we have to do is actually, in some cases, perhaps crop our data sets to just the area that's overlapping. This might be a restriction, or it might be that we intentionally flew our data sets so that we cover this area, and then there's some just extra that we can trim away. In some cases, we might actually need data in some of these other areas. And so we have to then do some kind of clever processing techniques. Maybe we discard images that don't cover this area, for example. But somehow we have to put all of our data sets into the same reference frame and system. And of course, this is why ground control points and datums are so important. You can watch some of the other videos about those topics. This is why having accurate ground control, having accurate datum information is so important when collecting these data sets, because if you've collected these data sets through time and then you misregister, you misalign these data sets, you won't be able to say anything essentially about changes through time. Once we've done this, though, we can then begin to look at individual pixels and how individual pixels have changed through time. So here's just a couple examples. Maybe here's one on the top, on the bottom would be this one here, where you have plants growing through time and then getting harvested, and you are sort of seeing the tops of those plants. Here's another one here, which looks like maybe a road of some type. And so maybe here you had something going on in this region. This could be, I don't know what this is in this particular example. This could be a noise. This could be a vehicle that was parked there at one point. For example, that probably makes sense given the scale here. But then otherwise, other than this anomaly, you've got pretty much constant heights across this area. So that's what you would expect for a road. There's probably a car parked here when that image was taken. What kinds of analysis can you do with time series data? You've already got all the normal types of analysis that you can do with a single image, but there is some additional analysis that you can do with time series. So for example, you can look at means and standard deviations, but a big one is trends. How are things changing through time? What is the trend through time? Or going back to our time series example here, we might want to look at what was the maximum versus the minimum elevation in a particular image, or the maximum versus the minimum optical reflectance in a particular image, or the reflectance at a particular spectral band, or the temperature. If this was thermal data, we could look at time series of temperature and look at the difference between the maximum and minimum. So these kind of minimum maximum statistics, time at minimum, time at maximum, that's all important or can be important. But then trends and cumulative offsets, those are also really important time series. So we might want to look at trends through time, velocities. If we're looking at how elevations are changing through time, we can look at, whether that's slow-moving landslides or sinkholes, or groundwater related subsidence. We can look at all these processes and how those are changing through time. We can also do things like differencing. So maybe we're not interested in a whole time series, but maybe just before and after. So this is very common in earthquake studies, which is my area of research. We do before and after the earthquake. We can see how the ground has changed. We can do before and after crops have been planted or harvested and see what was the change. Where were the crops the highest, for example? We can do analysis of crops. We can also do different kinds of things. So here's an example where we use an envelope to show all the cars that have ever been parked at a site. And so this is just one example of how you might actually take multiple images of a site and use that to get information on that site over time, how it's changing, how the dynamics are working there. We can also, as I mentioned, use regression. Time series regression, that's referring to, again, this idea of trend analysis through time. So we're talking about systematic monitoring of a site. We want to know when changes might be close to linear, when there's nonlinear things happening. We can mask areas within certain height ranges at different times, right? So we can do different kinds of analysis given time series or given change data. And the great thing about this kind of time analysis is that it doesn't depend on what type of data we're using. So we might be looking at multispectral data. Here's again some examples with multispectral imagery where we're looking at different machine learning models through time and where different areas are changing. Time series vector features for annual cultivated land mapping. So trying to identify where's the cultivated land basically based on the time series of multispectral data. We can look at many different types of data and do time series analysis with this data and use that data for models of subsidence or whatever we're looking at. So that's it, I think, for this lecture. So multitemporal analysis, it's just adds another dimension literally to the work that we can do with UAV-based data. If you've got some good examples of using UAV-based data for doing time series analysis, post those in the comments of the video and let me know what that's like. Thanks.